unleashing humanity from the tyranny of gravity. We are LiftPort. Okay, so it took us a while to get the details developed on the string. Once we had that, then we can go forward in actually designing the robot. We've been brainstorming for months and months and months, but until we actually knew the details, we couldn't start ordering parts. So that's really where we're at now. So the design looks something like this. You've got a primary spine, and I'm enlarging this, so just bear with me. The spine is about 1 inch wide, and there's some important details on this spine. It looks something like this. It's 1 inch by 1 inch, but it's not solid. It's not a solid aluminum rod. There's some cutouts. I'm not a very good artist here. There's some cutouts, so you'll actually lose a lot of the weight, a lot of the mass. But that's really important. These cutouts are very important because we can use these cutouts to anchor other elements to this, okay? So this is a top-down view, this is the side view, and what you're gonna have is you're gonna have a plate coming off of the spine, and the motor, this is the motor mount. The motor's only about as big as my thumb, maybe a little bit larger. It's got 3 elements to it. And then the disc. The disc is about 6.5 inches across or so. Keep this in mind. So this disc, about 1 centimeter wide, 1/4 inch wide or so, and there is a channel carved into the disc, so that the edge of the channel actually has the groove where the ribbon will actually flow through this whole thing right on the edges, on the outside edges, as this disc is turning. Okay? So imagine this as, obviously I'm not drawing this to scale because there's not enough room. We're going to have 10 motors, 10 discs, and then, so this is the motor and the discs. And they're almost but not quite touching it. What's going to happen is the ribbon will come down from the top, flow around the edge, pass to the next disc, to the next disc, to the next disc, all the way down through all 10 of these. And that's the base design. Now, we've always struggled with something like this because we have what we refer to as the no-cheater solution, where the technology that we use on Earth should apply to the system that we develop in space. Now, we decided that a 6-foot robot was probably the limit of what we really wanted to accomplish because there's logistics considerations in there. We would probably take this same configuration, maybe add some more wheels to it, and then spread it out further for the lunar elevator. So we've compressed it, so we are kind of getting into a little bit of a cheater solution, but this design should translate pretty nicely to the lunar elevator when we actually get to start building it. So basically what we're taking is we're taking this configuration of the spine, the motors, motor controller, and the disc, flipping it sideways, and that's what you get right here. Now, there's also some other elements here. You've got you know, a battery pack, and you've got a communications array. Those elements still need to be added to this, but that's the base system. That's really what we're talking about. In total, you're going to have the spine, the batteries, the communications. There's going to be a guide system top and bottom. And that becomes the core of the overall system. We also want to remind people that there's a very distinct tilt that the ribbon undertakes. Because of the flow of the wind, it's somewhere between here and here. We tend to kind of, you know, we don't really care. We built the robot with enough tolerance. It doesn't really matter where it is in the angle. But we also build the robot with a very distinct top and bottom, left and right, so that the mass of the various disks, the batteries, the communication systems, we tend to put the batteries on the bottom away from the string. So these disks will be on one side and the batteries will be on the other. Same thing with the communications array. They're going to be weighted at the bottom on one side, so that there's a very clear top, bottom, front, and back. So that's where we're at. We're making some really solid progress with the robot now that we have finally have the string. I'll let you know how it goes. Take care. Bye.
See, at LiftPort, man, we hurdle every obstacle. There's a difference between difficult, hard, and the impossible. Improbable to put an obstacle on what you do. You can't tell me sky's the limit, 'cause we're going to the moon.